Hi, everyone. My name is Youssef, and I'm here to tell you about my research in accelerating quantum algorithms, the next generation of computers. Now, quantum computers, like the one shown here in the top middle, they promise a massive, up to an exponential performance improvement in several important applications today, including drug synthesis, protein folding, artificial intelligence, and many more. They work by exploiting quantum phenomena like superposition and entanglement to enable a whole new class of algorithms to be performed, quantum algorithms, which will enable us to scale up these applications massively up to tens and hundreds of times. Now, the fundamental unit of quantum computing here is the qubit, or the quantum bit, which, thanks to superposition, a phenomena because of quantum mechanics, can exist in the states 0 and 1 at the same time, similar to how Schrodinger's cat from that metaphor is both alive and dead at the same time. And the real power comes in when you have several qubits working together. In fact, each additional qubit doubles the number of states available for us to compute on, giving this exponential rise in power. And in fact, at 300 qubits, the number of states that you can represent is greater than the number of atoms in the observable universe. And so we compute on these qubits using quantum gates, which form quantum circuits, like the one here in the bottom left. However, the quantum computers that we have right now that can work with these quantum circuits are still quite small, very expensive to make and maintain, and quite error-prone. And so there's a good need for simulating these devices on our current classical hardware, to be able to study them efficiently, to research quantum algorithms for the applications I mentioned earlier. Now, unfortunately, our common everyday computing devices that are powered by traditional CPUs and GPUs, like the ones shown here in the top left, which, by the way, also power our high-performance computing centers, are not very efficient at simulating quantum computers, neither in terms of time efficiency or energy use. And as you'll be aware, energy consumption is very important today. However, there are these other types of devices called field programmable gate arrays, or FPGAs, which actually allow us to reprogram the circuitry in the processor in order to create a very customized and specific architecture for the application that we want to run, in this case being simulating these quantum computers. And in theory, these FPGAs can give us much faster execution times, up to 10 times faster, but also because the circuitry is that much more customized, we can expect about 5 to 10 times better energy efficiency. And this will allow algorithm researchers from many different fields, including all the applications I mentioned above, to accelerate their experimentation with quantum algorithms on much more accessible hardware, and ultimately accelerate this development of the next frontier of computing. Thank you.